Maximum minimum using algorithm. A swimming pool is treated periodically to control the growth of bacteria. Suppose that T days after a treatment, the concentration of bacteria per cubic centimeter is C of T equals to 30T square minus 240T plus 500. Find the lowest concentration of bacteria during the first week after the treatment. Now here what we need to find is absolute minimum when we say lowest concentration, right? And this absolute minimum is during the first week. That means our time is greater than or equal to 0 and is less than or equals to 7 days, right? Now, so what we will do is we'll try to find the first derivative of this and equate it to 0 to find the critical number. And once we have critical number, then we will test the value of the function at the critical number and at these boundary conditions to see which one is the least, right? So here the function is C of t equals to 30t square minus 240t plus 500. So C dash of t is equals to 60t minus 240, which we can factor and write this as 60t minus 4. So that shows that for critical number, C dash t should be equals to 0. And that means that could be 0 if t equals to 4. Let's equate this first. So that gives us a value of t equals to 4, right? Only then it is going to be 0. So now we'll use the algorithm to find maximum and minimum. The algorithm is that in a closed interval as given here, which is 0 to 7, if the function is continuous, the function is a parabola, it is continuous, then it will have maximum, absolute value of maximum or minimum within the interval, and it will have in fact both in this particular case within the interval at one of these points or at a critical number which is t equals to 4. So now we need to find the value of the function at 0, at 4 and at 7, right? So for that we can use the calculator and calculate each value. Well, for 0, when t is 0, these two will be 0 and we are left with 500. So 500 is the initial count. Now for 4 we have 30 times 4 square minus 240 times 4 plus 500 gives us a value of 20. And for 7 we get 30 times 7 square minus 240 times 7 plus 500 gives us a value of 290. So we got these three values, and from here we can clearly see that it has a maximum of 500, minimum of 20 within this closed interval, right? And at 7 we get a value of 290, right? So find the lowest concentration of the bacteria during the first week after the treatment is at after 4 days, right? And the lowest concentration of bacteria is 20, correct? So we can write down our answer as the concentration of bacteria per cubic centimeter, right? So we say concentration of bacteria per cubic centimeter is lowest after 4 days, right? And it is 20 per cubic centimeter, right? So that's the answer. Now it's a good idea to sketch, and it's also written here. Okay, so it's a good idea to sketch and show how you get this. So let me just sketch this graph and show you how it will look like. So what we saw here is basically a function which is bound on the lower limit by 0 and the higher limit by 7. So at 0 we have a value of, let's say, 500. Yes, 500. The lowest value is when t equals to 4. let's say around here, it's very close to 0, and then it increases thereafter. So we can have a curve like this, right? So where we can say this is the initial value at 0 of concentration of bacteria when the swimming pool was treated, right? And this is the value at 7, and here we have a lowest count, which is just 20 here. At this is 500. It's not to the scale, and this value is 290 at 7. So that is the kind of graph which we get. So it decreases, the concentration decreases initially, is minimum after 4 days, and then starts increasing. So that is how we can do these kinds of questions using maximum minimum algorithm, right? To summarize, the algorithm is that we first find the boundary conditions, as in this case. First week means 0 to 7 days. And then we find the critical number, that is equating your first derivative to 0. And once we find the critical number and these two boundary conditions, then we need to check the values at these points. The lowest of these will be the least or the absolute minimum, and the highest will give you the absolute maximum. In this particular case, we were interested in lowest concentration, and therefore we had this answer C4 equals 20, right? So that is how we need to do such questions. Thank you and all the best.